Hello, ladies and gentlemen. It is me, Ivan, your host. Welcome back. So, in the last episode about Mars, we discussed its topography, its surface features, and even what the ancients thought of it. But today, we'll be talking about Mars's moons and the asteroid belt. So, now, please sit comfortably and let's begin. So, Mars has two moons, Deimos and Phobos. Phobos is the largest and closest to Mars, while Deimos is the smallest and farthest from Mars. Phobos is approximately 23 kilometers across in diameter and it is approximately 9,000 kilometers away from Mars. While Deimos is 15 kilometers across in diameter and it is approximately 23,000 kilometers away from Mars. Now, unlike most moons we see in the solar system, Deimos and Phobos have irregular shapes. They are shaped like potatoes, if you will. And the question is, why are they shaped so irregularly? Well, the answer is, the reason why these moons are irregularly shaped is because of their size and their gravity. Since they are so small and so weak in terms of gravity, they cannot be curved into balls like most planetary objects are. So that's why. And now, the future of these moons is pretty bizarre. You see, we are discovering that Phobos is in a collision course with Mars, while Deimos is getting farther and farther away from the gravitational field of Mars. In other words, in 100 million years or so, in either case, Phobos will collide with Mars and Deimos will have left the gravitational field of Mars. In other words, in 100 million years in the future, the planet Mars might be moonless like Venus and Mercury. But right now, in the coming decades, it can be very useful in the solar system exploration. For people like Elon Musk who are trying to investigate about Mars to see if it's possible to live there, Phobos and Deimos can serve as bases to study the conditions on Mars and see how the spacecrafts and all the resources can get adapted. So these moons might be very helpful in the colonization of Mars. But remember, as in the last episode as I mentioned, it's extremely hard to even colonize the moon itself. So now, enough talking about the moons of Mars, let's talk about the asteroid belt. So, in the 19th century, astronomers started seeing that Jupiter and Mars are extremely far from each other. So far, in fact, that was incredibly unusual. Something had to be in that empty region between Mars and Jupiter. But turns out it wasn't a planet like most astronomers suspected to be. It was a little dot. This object was incredibly small, so small that it was seen like a small little star, even in the lens of a telescope. And that's why they named them asteroids, which actually means star-like, since they looked like little stars in a telescope. So what are these asteroids? We think that these asteroids are quite literally the fossils of our cosmic backyard. These are the fossils in our cosmic backyard indeed, since they are so old and they have orbited the sun for such a long time. It tells us a lot about how the solar system formed. Meteorites that crash into the Earth show us that asteroids are much more different than the rocks that we see here on Earth. But you see, asteroids are categorized in a lot of ways based on many things. There are some classifications based on orbits and other classifications, well, based on the elemental composition. Some asteroids are made of carbon, others are made of silicon, others are made of metal. So you see, they range in different elemental compositions, but not only that, they also range in shapes. An example, Cleopatra. This weird asteroid is shaped like a bone. Most of them look like potatoes, much more similar like Deimos and Phobos. But instead, this Cleopatra asteroid is shaped like a bone. And you see, in the solar system, quite anything is possible. So in other words, this Cleopatra asteroid is shaped in a bone shape. So, even asteroids range in orbit. Some asteroids orbit incredibly near the Earth, near Earth asteroids. And some objects can orbit near Mars but are past the orbit of Mars. So they range in different sizes, shapes, and orbits. But the interesting thing is that they're past. Approximately 4 billion years ago, after Jupiter formed, the gravitational influence of Jupiter made that pile of rubble and rock not coalesce into a planet, and thus making the asteroid belt. So, this episode is quite short, so that's generally it. So, let me leave you a question. Tell me, we have seen in the past that many asteroids can actually collide with the Earth, many as big as the Mount Everest. Then the question is, can these asteroids be helpful? What do you think they can help the Earth? So the question is, we are seeing that these asteroids that hit the Earth are very important to life. How are they so important? Please, write in the comment section down below, and we'll find the answer in quite literally the next episode. So, I hope that you liked this video. Please click the like button, subscribe, and share with your friends, and please support me on my Patreon page. Thank you.